Okay, so we're going to look at this count the ropes method with a bunch of different compound pulley systems that are going to get increasingly more complicated. Some of them to the point of them being kind of ridiculous. But cool thing is, even these ridiculous ones we can figure out relatively easily with this method. So first, let's look at this pulley system right here. So we're going to go through the steps. So the first one is to identify the effort as well as any movable pulleys that move with it. So we've got the effort here. It goes straight to a fixed pulley, so no movable pulleys that move it with it. Next, identify the load as well as any movable pulleys that move with it. All right, so we've got the load here, and this movable pulley goes with them. Next, find a fixed pulley in between these two areas and split the system here. So when talking about these two areas, I've got this one area that's just the effort, and then this other one that's the load and the movable pulley that goes with it. So it says to split it at a fixed pulley. So we'll just go like this. Split. All right. So now we have our two different sections, our effort section and our load section. Now we can just identify the different ropes. So it says to ignore any segments that go from one fixed pulley to another. Okay, well, there's only one fixed pulley in this thing, so it's not really possible for anything to go from one fixed pulley to another. So all of these segments are going to get used. We're not going to ignore any of them. So we're just going to mark the ones that are on the load side. I'm just going to color over them in red for load. And then we've got one on the effort side. Okay, so we've got our ropes in and our ropes out. Mechanical advantage is just out over in. So we got mechanical advantage equals out, which is 1, 2, over in, which is just 1. So in the end, we have a mechanical advantage of 2 for this one. All right, so let's ignore that one now and look at this next one. Okay, same thing. We're going to figure out which of the movable pulleys are moving with the load versus the effort. So we've got two fixed pulleys, one movable, and it's attached to the load, so it's definitely going to be moving with the load. So everything kind of here-ish is going to be the load side of things. Now next, we find a fixed pulley in between those two areas. So we've got two fixed pulleys now. We've got this little one, but that isn't really in between the areas because, we've kind of got things going on with the load and the movable pulley kind of on both sides of it. This one, however, if we split it here, which we're going to, then we have both of these that are going to the movable pulley on one side of the split, which is the same side as the load, and then everything else on the other side. So now we'll just mark what we have. Well, first we're going to look for any segments that go from one fixed pulley to another. Let's see, this goes from effort to fixed, fixed to movable, movable to fixed, fixed to load, basically. All right, so that doesn't apply to any of them in this case. So we're just going to color code all of them. And then same deal as before. MA equals ropes out over ropes in. So we've got 3 out this time and still just 1 in. So MA equals 3. Cool. So now, moving on, let's look at this next one. Okay, let's go through the steps again. So we've got the effort here, no movable pulleys moving with the effort still. But we've got the load, got these two different movable pulleys, both attached to the load, both moving with it. So where we're going to split it, our fixed pulley between these two areas is going to be right there. So we've got the effort side, then all this is load side because this pulley is attached to the load, this is leading to that. Anyway, this is all load side. So same deal as before. Got 1, 2, 3, 4 of these guys. Just one of these. And we go boop. A equals MA equals 4. So far, all of these have had a mechanical advantage greater than 1. And you have noticed also that all of them have had the movable pulley on the load side. That's not a coincidence. The movable pulley is kind of where the mechanical advantage more or less comes from. Now we're going to look at another example. So you notice this is the same arrangement as before, but now we've got the load on this end and the effort here. So let's go through the steps. Identify the effort and any movable pulleys. Um, you know what? I'm going to start marking which team all these movable pulleys are on to. It's on team load, team load. All right. Now we're going to do this one. So we've got these two that are attached to the effort. So they are on team effort. Probably can't see that green color super well. Then we're going to split it the same place as before. So we've got all the effort stuff happening here, load stuff here, fixed pulley in between. Let's mark all these. 1, 2, 3, 4. 1. Now this time, instead of having 4 over 1, we have 1 over 4, which makes sense because the position of these guys was reversed, so we would expect the mechanical advantage to be the inverse. Here we've got MA equals. Okay. Now, these are all fairly realistic pulley systems that you might actually see. So are some of the other ones, but we're going to move on to some other ones where things start to get a little bit more complicated. Okay, same deal. Identify the effort, any movable pulleys that move with it. Okay, well this one, this effort rope goes straight to a movable pulley, so it seems like this one probably moves with it. So we'll put that one on team effort. All right. Identify the load as well as any movable pulleys that move with it. All right, well, this one's attached, so that one's definitely load. And wait, this one's also attached. That's got to be load too. But we already decided that it's effort. Well, it turns out that it's actually both. So in this case, that's where we go to this clause or whatever we want to call it here. So instead of finding a fixed pulley in between the load stuff and the effort stuff, in this case, there's not one because load and effort both meet at the same pulley. So we're going to do what it says here. In this case, split the system in the middle of the rope between the effort and this pulley. So we're actually going to split it here this time. Now we're going to still go through and mark, color code all these ropes. We've got load, 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 and this guy's also load. And then we've got effort. So the length of these segments doesn't mean anything. It's only the how many segments there are. So we've got, put it up here this time. We've got MA equals out over in, so out. We've got 4. In, we've got 1. This segment here is kind of pulling double duty. It's working for both teams because this movable pulley is attached to both. So it's moving with both of them. Anyway, so we got 4 over 1, which obviously is just 4. Now we're going to look at another example. In this example, notice, so the last one, we had the effort moving in the same direction as the load. That might be a giveaway that we have a movable pulley working for both teams. Now we're going to look at this same one here. Okay, we have the effort moving up, and we can kind of tell that if you pull this rope, the load is also going to move up. So they are working in the same direction again. So it's possible we'll have to split along the way. But we'll see. We'll go through the steps. All right. So we've got identify the effort as well as any movable pulleys that move with it. Effort's here. We got these 2 movable pulleys, but they're not really moving along with it directly. They're going to move in that same direction, but not directly. So I don't think we're going to put this one on team effort. Now, we're going to look for the load as well as movable pulleys that move with it. Well, both of these are attached to the load, so we're going to put those on team load. Now, last, we haven't had to do this one yet because it hasn't applied, but we're going to look at step 2. Ignore any segments that go from one fixed pulley to another. We've got a fixed pulley here. This pulley is fixed there, and this pulley is fixed there. So in between these, nothing's really moving. The rope is just passing through, but the length of that segment is not changing like it's going to be doing here. All that's happening is it changes direction. So this segment is going to get ignored. So here we've got fixed to movable, fixed to effort. Yeah, okay, all the rest of these are going to get counted. And we've got 1, 2, 3, 4. Oh, don't count that one. And so we can see now that the result between these 2 cases actually ended up being the same. And if you look really closely, you can tell that it makes sense because these are actually really kind of the same situation. So if we were to take like this part here, just the load section. Got the load attached to two movable pulleys, fixed one in the middle, and then just an attachment point on the other end. Okay. Let's see. Load, two movable pulleys, fixed one in the middle, attachment point on the other end. Okay, these are kind of the same thing. The only point at which they get different is at this rope, where we split this one. But if we think about how these fixed pulleys are basically just pass-throughs, we can almost just like delete the fixed pulleys themselves. And if we do, this entire thing becomes one segment. And now we can see that these two things are actually the exact same thing. Just this is a weird squiggly curvy segment to get there, but it's one green segment with the effort going up, and then these are the same, which is why we ended up getting the same answer. All right, so we're going to look at another one. This one at first glance is going to look pretty gnarly, kind of complicated, but as we start to do the steps, we're going to realize it's not too bad. Okay, so identify the effort and movable pulleys that go with it. So we've got an effort that goes to fixed, to fixed, to fixed, to fixed, to fixed, and then the movable is there. But that one's attached with the load, so we're going to do it red. We're going to put it on team load. All right, so that was identifying the load and its movable pulleys. Find a fixed pulley between these two areas and split it there. So notice it says find a fixed pulley, not the fixed pulley. We've already assumed from A and B that we've already got all the movable pulleys on one side or another. They've already been split into their teams, which means that we could split this at any of these fixed pulleys, and it's going to be just fine. It doesn't matter which one we use. So let's just split it here. Now the reason it doesn't matter also comes down to step 2. Ignore any segments that go from one fixed pulley to another. Okay? Fixed to fixed, ignore. Fixed to fixed, ignore. Fixed to fixed, ignore. Fixed to fixed, ignore. Now the reason, once again, why we're ignoring all of these is because the length of the rope isn't really, the length of these individual segments is not changing, which means nothing's happening in between these points to change our input displacement versus our output displacement. So nothing's happening mechanical advantage-wise. Basically, the rope is just passing through. This is the same thing as just taking this rope that we have here and just stretching all of these things out straight and pulling it that way. It's effectively the same thing. It's just pass through. So we're just going to ignore those. Now we're going to mark all of the segments that don't have black X's on them. So we've got this one here with the effort, and this one here with the load. We get MA equals 2 red divided by 1 green. So MA equals 2. Looked really complicated, but a lot of this stuff just canceled out. Now you might be asking, like, well, if this cancels out, like, why would you do all of this stuff? Well, maybe you've got other things going on in this room. You've got some sort of big old machine or something here in the middle of the room, so you got to run the rope along the walls just so it's out of the way of everything. Pulleys are good for that. All right, last example. We're going to look at this monstrosity. Let's go through the steps. So identify the effort as well as any movable pulleys that go with it. All right, so we've got the effort here. It's connected to this bar that's connected to both of these guys. So since they're connected, we're going to say those are definitely team effort. All right, now we're going to identify the load as well as any movable pulleys that move with it. All right, so we got load. This movable pulley is team load. Find a fixed pulley in between these two areas and split the system there. Okay, so we've got a few fixed pulleys. We got this one, but it's got team effort on both sides of it. We got this one, but once again, both of these ropes are going to this load movable pulley, so it's got team load on both sides of it. That's no good. We can't split it there either. This one, we can. Split. Now we mark. And we mark. And now we can figure out our mechanical advantage. So MA equals out over in, which is red. We've got 3 of them. Over our green, got 4. So MA equals 0.75, 3/4. Ta-da.